My name is Usama bin Hassan. My student ID is ST20291482. Today I am going to present on my research topic, basically which is dissertation topic as well, and that is predicting house prices using regression models using machine learning. This study is based on the UK House Price Index, and the main aim is to compare different models to find which one gives the most accurate predictions. So here I am going to start with my slide, which is background and problem. Traditional economic models are often too simple for today's housing market. House prices depend on many factors such as size, type, location, and these relationships are often complex and non-linear. Machine learning helps solve this problem because it can capture both linear and non-linear patterns. So this research focuses on comparing different models to improve prediction accuracy. Now I am moving toward aim and objectives. The main aim of this study is to test different regression models techniques for predicting house prices. The objectives include preparing the dataset properly, applying multiple regression techniques, and evaluating their performance using standard metrics. Finally, the goal is to identify the most reliable model for real-world housing price prediction. The next heading is literature review. Previous research shows that the house prices are mainly influenced by structural features like property type and size. However, traditional models often fail to capture complex market behavior. Machine learning models, especially ensemble methods, perform better because they combine multiple models to improve prediction accuracy and stability. Now I am moving towards research gap. One key gap in existing research is the role of location data. Many studies do not fully use spatial information even though it has a strong impact on house prices. Also, model tuning and comparison are often not explored in detail. So there is need for better evaluation of models using both spatial and time-based features. Moving further toward methodology. This study follows a quantitative time series approach using UK House Price Index data. That is basically data is used to test it. The dataset contains historical housing prices across regions over time. First, data pre-processing was carried out. Missing values were handled using forward fill, which ensures that the time order of data is preserved without any gap. Next, feature engineering was applied. I created lagged variables which use past house prices to help predict future values. This is important because the housing market often follows time-based trends and momentum effects. Feature scaling was also applied where necessary to ensure all variables are on a comparable scale, which improves model performance. Finally, the dataset was split using time series cross-validation, which prevents data leakage and ensures the future data is never used to predict the past. Now I am going to talk about models and evaluation. Models that basically I have used here. I used several regression models for comparison of prices. First, I used linear regression as a baseline model. This helped understand the basic relationship between variable and prices. Then I applied ridge and lasso regression. These are regularized models that help reduce overfitting and handle multicollinearity between variables. After that, I used more advanced machine learning models like random forest and XGBoost. These are ensemble methods that combine multiple decision trees to improve accuracy and handle complex patterns in data. To evaluate all models, I used RMSE and R squared. RMSE measures the average prediction error, so lower values mean better performance. R squared shows how much variation in house prices is explained the model, so higher values are better. Time series cross validation was also used to ensure the evaluation is realistic and consistent with real forecasting conditions. Now I am moving forward the results. The results were quite interesting and slightly unexpected. The simple linear and regularized models actually performed better than more complex machine learning models like random forest and XGBoost. The achieved lower prediction error and high overall accuracy. This suggests the dataset mainly follows a linear relationship, meaning prices change are relatively structured and predictable. Because of this, advanced models were not able to significantly improve performance. In some cases, they may have overfitted the data, capturing unnecessary complexity that didn't generalize well. Overall, this shows the model complexity does not always guarantee better results, especially when the underlying data structure is simple. Now I am going to talk about feature importance of this study. From the feature analysis, structural features such as property type had this strong influence on price. High value properties like detached houses contributed more significantly to overall market trends. Past price values were also very important, showing that the housing market follows a time dependent pattern. Now, if I talk about conclusion, or the conclusion of this study is that linear and regularized regression models were the most effective for this dataset, as also I have described in result. The study shows that more complex models are not always better, and performance depends heavily on the nature of the data. Time-based features play a key role in improving prediction accuracy. Overall, house prices are mainly driven by structural characteristics and historical needs. Now I am going to talk on feature work. Future work. This research can support policymakers, investors, and financial institutions in making better decisions in the housing market. One advantage is that the models used are interpretable and easy to understand. However, a limitation of this study is the lack of detailed geographic data. In future work, integrating spatial data and local level information could significantly improve prediction accuracy and make the models more realistic for real world applications. Here are at the end of some reference link that I have attached. Thank you for listening me.